6.2, just basically say the rest of what I need to say about matrix inverses. So that's what I'm going to do. So here we go. So yesterday I introduced matrix inverses, which was a claim that was basically going to be our way of doing division for matrices, sort of division anyway. So just so you remember, if A is a matrix, if A is a square matrix, then its inverse is a matrix, is also a square matrix. And it satisfies the following two things, just to remind you guys of what we did. If I multiply A by its inverse, then I get the identity matrix. And if I multiply it the other way, then I also get the identity matrix. So this sort of defined the inverse for us. This is what makes the inverse the inverse. That if I multiply it with A, either way, I will get the identity matrix back. Okay. And as I mentioned yesterday, this only makes sense if A is a square matrix. If A is any other size, there's just no inverse. I can't talk about inverses. And that's a consequence of this formula here, or I guess these two formulas. Okay. And yesterday I told you guys about an algorithm for computing this from a given matrix A. And basically what I want to start off with today is doing a bigger example. I did an example at the end of class yesterday. I did a 2x2. I figured today I'd just start off class by doing a 3x3 example just to get a little bit more feel for how this thing works. But all it boiled down to was row reducing. That was our algorithm from yesterday. So let's walk through the algorithm on one more example just to get used to this. So here's a 3x3 matrix. 0, 3, 6, and 2, -8, 16. All right. So maybe this is our matrix A, 3x3. It's a 3x3, so I can, in fact, find, well, potentially find an inverse. We'll talk a little bit more about that in a minute, about when there's not an inverse. But let's go ahead and try to find the inverse using the algorithm that I described yesterday. And we'll see what happens. So what am I supposed to do? I'm supposed to take this matrix and I'm supposed to augment it into this matrix, where on the right side, I put in the identity matrix of the appropriate size. So that's a 3x3 identity matrix that I should be adding over here. And this is the first step of the algorithm, is to write down this matrix. The matrix A on the left and the identity matrix on the right. Now what I'm supposed to do is try to reduce. I want to reduce the left-hand side. My goal is to make the left side look like this. Basically, I want to move the identity to the left if I can, by using the row reduction techniques that we had from chapter 5. So looking for the leading ones in every column is what I'm trying to get. And if I can succeed, then whatever ends up here on the right, that'll be the inverse of A. So let's go ahead and do that. So let's try to reduce this thing. So I'm really interested in reducing the thing to the left of the bar, like we did in chapter 5. And the stuff on the right is just sort of along for the ride. Well, it'll change as we go, and we'll just see what we get. Okay, so let's start. First thing, I need a leading one. I already have one. So first step is complete. Next thing is I need to make a 0 in the column. So this 2 needs to be a 0. So let's take -2 times 1 will cancel 2. So let's take row 3 minus 2 row 1. Multiply the first row by -2 and add it to that third row. And what will happen? Well, I'll get a 0 here, because -2 plus 2 is 0. 0 plus -8 is still -8. And -2 times 2 is positive 4. And so I will get 20. 4 plus 16 is 20. And then I have to take care of over here as well. -2 times 1 is -2, so I'll get -2. And then these zeros won't change anything, so I'll get 0. And then the rest of my matrix doesn't change. So here's my new matrix. I've finished the first column. Looking good so far. Let's move on to the second column. I want a leading 1 right here, where this 3 is. So maybe to get a 1 here, I'll just divide this row by 3. So let's divide by 3 on the second row. And what do I get? I get 0, 1, 2, 0, 1/3, 0. So, I'll warn you guys now, if you haven't already noticed, when we're doing these matrix inverse computations, you're going to have fractions. It's just part of the game. We're going to have fractions. Like we have this 1/3. There's going to be some more that pop up. And so if you're still, maybe I'm preaching to the choir here and you guys are already good with fractions, which is great if you are. If you're not so comfortable with fractions, now's the time to sort of get over your fear, because fractions are going to be all over the place. And we're going to have to deal with them for the rest of the semester. So anyway, here's my new matrix, just dividing that middle row by 3. Okay, now I need a 0 where this -8 is. If I want to take care of this middle column, I need a 0 here. So let's take +8 times the second row and add it to the third row. So that 8 times 1 is 8, plus -8 will give me 0. So I'll get 0, 0. Let's see, 8 times 2 is 16, plus 20 is 36. It's scary when we get big numbers like that. That's okay. 0, this will be -2 still. What's 8 times a third? Well, that's 8/3, and I can't reduce that fraction. So 8/3 is what I'll get here. And then 0 plus 1 is 1. And then I didn't change anything else. Okay. Oh my goodness. Clean this up a little. There we go. Okay. So here's my new matrix. We're almost there. It looks like it's going to work out. I should be able to get a leading one here. I'm going to have to divide by 36, which is maybe slightly annoying. But that's okay. We will deal with our fractions. I'm going to rewrite that matrix up here just so I can start in the left corner. That just makes more sense to me. So just rewriting that last matrix real quick. I can erase everything else. Okay, so now I need a 1 where this is, like I said, we'll divide the last row by 36. Oof, okay, that's gonna be, I picked bad numbers, but that's fine. I guess I shouldn't say that. There's no such thing as bad numbers, right? This will still work out. We'll just have to be good with fractions. So divide everything here by 36. What do we get? We get 0, 0, 1. And then what's 2 divided by 36? Well, half of 36 is 18. So I should get -1/18. Yeah, -1/18. And then 8/3. Let's do this to make this clear so I don't just say it out loud for you guys. What's 8/3 times 1/36? Well, if multiply fractions, we could just go straight across. But on the other hand, I could sort of cancel out. 8 is 2 times 4. 4 goes into 36 9 times. Yeah. So I could divide out the 4 and the 4. And what do I get? I'm left with 2/3 times 9. So I'm going to have 2/27, I suppose is my answer. You guys can double check my work there. I believe I get 2/27, doing this quickly in my head. So 2/27 is what I get. And then I'll get 1/36 is the last one there. Okay. You guys being online, you may prefer to put that in a calculator, but I encourage you to get used to doing some of these not with a calculator. It's good to be able to do these kinds of fraction computations. Okay, so here's my last row. And 0, 1, 2, 0, 1/3, 0, 1, 0, -2, 1, 0, 0. Okay. So now I just need to get zeros here where it's 2 and -2 are. So -2 will cancel out the second row, row 2 minus 2, row 3. What happens? I should get 0, 1, and then I'll get 0. Now I'm going to do 0 plus, so -2 times 1/18 is +2/18, and 2/18 reduces to 1/9. I get 1/9. All right, so here's one where I need to show you guys the work. Is I need to do 2 times 1/3, so that's 2/3, plus 2 over 27. Rewrite this as a fraction with a 27 denominator. That means multiply both of these by 9. I get 18 over 27 plus 2 over 27. It looks like 20 over 27. So 20 over 27. I always try to cross my 7s because sometimes they look, I don't know. I don't know if everyone does that, but I cross my 7s so they don't look like 1s or something. Anyway, 20 over 27. And then negative 2 times 0, or hang on. Wait, hang on. Did I do the wrong computation here? I'm multiplying the third row by negative 2 and adding it up. I did do the wrong computation. No one stopped me. That's okay. Sorry. I should have done negative 2 times the 2 over 27 and add that to 1/3. So it should be 1/3 minus 4 over 27. Now we do, this fraction will be 9 over 27 minus 4 over 27. I get 5 over 27. Okay, that's better. 5 over 27 is what I get there. And then negative 2 times 1 over 36 will just give me negative 2 over 36, which is negative 1 over 18. Okay, cool. And then I get 0, 0, 1, 118, 2 over 27, and 1 over 36. And 1, 0, 2, 0. All right, so we're almost there. There's one more step, which you guys can probably guess what it is. We'll just multiply it by positive 2 and add it to the top row. So we'll do row 1 plus 2, row 3. And what do we get? Well, this top row would be 1, 0, 0. Then I need to do 1 plus, well, let's see, negative 2 times negative 1 over 18. That's 1 over 9. 1 plus 1 over 9. I think that's 10 over 9. Let's see. Negative 2 times 2 over 27. That's negative 4 over 27 plus 0. That's negative 4 over 27. And then lastly, negative 2 times 1 over 36. That's negative 1 over 18. And I just add that to 0 to get negative 1 over 18. And then I'm done. Okay. And I'll write in the rest of this.
Is it positive 1/18 in the top right and positive 4 over 27 because didn't we multiply by a positive 2?
Yep. Sorry, I looked at my wrong step. Thank you very much. That should be positive. This should be positive. Yes, because we did positive 2. Thank you. Okay. So you can see it's easy to make little errors.
And it's also 1 minus 1 over 9.
All right.
At the first element of the inverse.
So Demetrios, which entry are you talking about?
First row, first column of the inverse matrix.
So it's 10 over 9?
Yeah, that's 1 minus.
1 minus, yeah, thank you. So I was looking at this when I did this computation, so I completely threw myself off. Yeah. So this should be 1 minus, since I'm multiplying by positive 2, this will be minus 1 over 9. So 1 minus 1 over 9, and that should be 8 over 9. So thank you. So yeah, if I ever make mistakes, just stop me, because it's easy for me to keep going. Happens to the best of us. Okay, I think that's good. I should have tried to pick a less messy example. Here we go. So we succeeded in getting the identity matrix on the left side. We got 1, 1, and then 1, 1, 1, and then zeros everywhere else. So this is fully reduced, and it's the identity matrix, meaning that this must be our inverse matrix. So just to summarize, A inverse equals that thing over there. So that's 8 over 9, 4 over 27, 1 over 18, 1 over 9. Let me give myself more room. 5 over 27, negative 1 over 18, negative 1 over 18, 2 over 27, 1 over 36. Bam. Okay. We found our inverse. So this would be the part where I tell you